The human race has always had an unstoppable urge to explore and discover. But it's only been in the past 100 years or so that we've been able to leave our home planet and venture out into the great expanse of space. It's a difficult thing to comprehend, the vast distances involved in even the closest interplanetary journeys. And it becomes even more difficult to imagine when you think about the size and weight of the vehicles we send to make those journeys possible. The largest rocket ever built by far was NASA's Saturn V moon rocket. Standing over 363 feet tall and weighing almost 6.6 million pounds, it was a technological marvel that allowed us to fulfill President John F. Kennedy's dream of sending humans to the moon and returning them safely back to Earth. But what if we were to send something similar to Mars? As impressive as the Saturn V rocket was, it would be dwarfed by the sheer size and scale of the rocket that would be required to send just one of NASA's most recent rovers to Mars. That's right, we're talking about Perseverance, the car-sized rover that has been exploring the Red Planet since February 2021. At a weight of over 2.7 billion pounds, it would take over 750 of the world's largest rockets to lift off and carry Perseverance to its new home. In this video, we'll take a look at how this incredible feat of engineering is possible. How can something as small as a rover weigh so much? And how will it get to Mars without being carried by a rocket bigger than any rocket ever built? So let's start with the basics. What exactly makes up the Perseverance rover, and how much does it weigh? To answer that question, let's break down the components of this amazing machine. The first is the rover itself. This is basically the body of the vehicle which houses all of the scientific instruments and equipment that will be used to explore Mars. The rover is made up of a number of different parts, including the body, frame, wheels, antennas, solar panels, cameras, and various other pieces of equipment. All of these parts are designed to work together to allow Perseverance to move around on the surface of Mars, collect samples, and transmit data back to Earth. The weight of the rover itself is approximately 2,260 pounds. Next, we have the cruise stage. This is the part of the spacecraft that will take it from Earth to Mars. The cruise stage is responsible for keeping the rover on course and providing the necessary propulsion to reach its destination. The weight of the cruise stage is approximately 2,200 pounds. And finally, there is the lander. This is the part of the spacecraft that will help Perseverance land on the surface of Mars. The lander is equipped with a number of different systems that will work together to slow down the spacecraft as it enters the atmosphere of Mars and bring it safely to the surface. The weight of the lander is approximately 5,800 pounds. Now that we know what makes up the Perseverance rover, we can start to understand how it weighs over 2.7 billion pounds. If we add up the weight of the rover, the cruise stage, and the lander, we get a total weight of 10,260 pounds. That's already a lot of weight. But that's not where it stops. You see, in order for Perseverance to function properly on the surface of Mars, it needs to carry with it a number of supplies that will allow it to operate for the duration of its mission. These supplies include batteries, fuel, scientific instruments, and other equipment. All of this equipment adds to the overall weight of the spacecraft. But that's not all. In addition to the weight of the supplies, we also need to factor in the weight of the atmosphere that the spacecraft will be traveling through. As the spacecraft travels through the atmosphere of Earth and Mars, it will be met with resistance from the air molecules. This resistance will create a force that will slow the spacecraft down. In order to account for this, we need to add a certain amount of weight to the total weight of the spacecraft to account for the energy that will be lost due to atmospheric drag. Finally, we need to account for the gravitational pull of the planets. As the spacecraft travels from Earth to Mars, it will be affected by the gravitational pull of both planets. The gravitational pull of Mars is weaker than that of Earth, so the spacecraft will actually gain speed as it approaches the planet. In order to account for this, we need to add a certain amount of weight to the total weight of the spacecraft to account for the energy that will be gained due to gravitational potential energy. Once we've accounted for all of these factors, we arrive at a total weight of over 2.7 billion pounds for the Perseverance rover. That's a lot of weight. And it makes sense now why it would take over 750 of the world's largest rockets to lift off and carry it to Mars. But wait, you might be wondering, how does a rocket get something as heavy as Perseverance off the ground in the first place? Rockets work by burning fuel and oxidizer in a combustion chamber. The hot gas that's created in the combustion chamber is then expelled out of the back of the rocket engine, which creates thrust that pushes the rocket forward. The amount of thrust that a rocket engine can produce is measured in pounds force. 1 pound force is equal to the weight of 1 pound on Earth. The Saturn V rocket, for example, had a thrust capability of 35,640,000 pounds force. That's enough thrust to lift the Apollo spacecraft and astronauts to the moon. To calculate how many rockets we would need to lift Perseverance to Mars, we need to divide the total weight of the spacecraft by the thrust capability of each rocket. In the case of Perseverance, we would need 750 rockets to generate enough thrust to lift it off the ground. But what if we could increase the thrust capability of a single rocket to match the thrust of 750 rockets? If we were able to do that, we would need a rocket with a thrust capability of 26,925,500,000 pounds force. That's equivalent to over 26 million pounds weight. To put that into perspective, that's heavier than the International Space Station, which weighs in at just under 420 tons or 840,000 pounds. But unfortunately, that kind of rocket doesn't exist yet. The most powerful rocket currently in operation on Earth is SpaceX's Falcon Heavy, which has a thrust capability of 5,160,000 pounds force. That's still pretty impressive, but it's nowhere near enough to lift Perseverance to Mars. If we wanted to use a single rocket to lift Perseverance to Mars, we would need a rocket that was over 5 times more powerful than the Falcon Heavy. And even then, we would still need to launch multiple versions of the rocket in order to get the full weight of the spacecraft off the ground. But let's say that we did manage to create a rocket with the necessary thrust to lift Perseverance to Mars. How big would that rocket need to be? To answer that question, we need to look at the largest rocket ever built, the Saturn V. As we mentioned earlier, the Saturn V rocket stood over 363 feet tall and was over 30 feet in diameter. It was truly a massive undertaking to build such a large and powerful rocket. If we wanted to create a single rocket that could lift Perseverance to Mars, we would need a rocket that was several times larger than the Saturn V. The exact size would depend on the thrust capability of the rocket. But to give you an idea, if we wanted a rocket that was 10 times more powerful than the Saturn V, it would need to be over 10 times larger in terms of both height and diameter. That means that the rocket would need to be over 3,600 feet tall and over 300 feet in diameter. Just imagine the size of the building you would need to construct in order to house a rocket like that. You would need a hangar that was over 100 feet taller than the Statue of Liberty and over 100 feet wider than a football field. It's really quite remarkable when you think about the logistics involved in building and launching a rocket like that. Not only would you need an incredibly powerful engine, but you would also need a strong and lightweight structure to withstand the forces involved in launch. And you would also need a team of thousands of people to design, build, and launch the rocket. But even with all that in place, you still wouldn't be able to launch Perseverance on a single rocket. You would need multiple rockets working together to achieve that. In conclusion, the idea of sending Perseverance to Mars on a single rocket is truly a monumental task. It would require a level of engineering and technology that we simply don't have yet. But it's always fascinating to think about the possibilities that lie ahead for space exploration. Who knows what kind of technological advancements we'll make in the future that will allow us to explore the universe in ways we never thought possible. What do you think? Would you like to see a rocket like this built in your lifetime? Let me know in the comments below. And don't forget to subscribe for more videos like this one. Thanks for watching.